We have the following problem, and it's if the DC collector current IC for an NPN BJT, this is important, so we are going to underline it, is in the forward active region, and it's equal to 8.0, so IC NPN BJT is 8.0 milliamps. That's another important part. And the DC base current, which is our IB, is equal to 95 microamps. Then what's the common base current gain, which is the alpha symbol for this transistor? Since alpha only varies slightly, we want to make sure to include decimal places. So if we look at the notes linked below, like button on about page 103, we have the following equations here. And we want to solve for our alpha, so we need to find one with our alpha in it. We also have our IC and our IE, so we're going to want to, or not our IE, sorry, we have our IB. So we want to use these as well. So if we look at this, there's two equations that we're going to be using. We're going to use our IE is equal to IC plus our IB. I'm just doing it in lowercase just to keep it simple. Our IC is equal to alpha times our IE, right? And we know we're given IC and IB, so that's what we're going to want to use. So we're going to have to substitute the top equation into the bottom equation because we want our alpha. So our alpha is going to be equal to, we're going to have our IC over our IE because we're just multiplying both sides by 1 over IE to get our alpha by itself. And now we can plug these things inside of here. So we're going to take this and plug it into here. So our equation is going to be alpha is equal to IC over our IC plus our IB. So that's going to be our equation. For this problem, when we plug it in, we're going to get that our alpha is equal to, we have our IC as 8 milliamps, so 8 times 10 to the negative 3. And this is going to be divided by our 8 times 10 to the negative 3, of course. And then we're going to have plus our IB, and our IB is 95 times 10 to the negative 6 for the micro and the microamps. And that's going to give us a value because our amps are going to cancel out, right? If we have amps on top and amps on bottom, they're just going to cancel. And we get a solid value of 0.98826 for our alpha. And that's how we would go about solving this problem. If you have different values, you would just substitute them in, but this is our general equation.